students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the second lecture on this chapter. In this lecture, we are going to discuss again a very important thing, that is the preparation of amines. Amines can be prepared in different ways by the use of different reagents, different process that we are going to discuss. Basically, we will cover 7 steps, 7 process by which we can able to produce the different type of amines. First, we will discuss the Hofmann aminolysis process. Secondly, we will discuss by reduction. Thirdly, we will discuss about the hydrolysis of isocyanides. Then we will discuss the Gabriel phthalimide synthesis. Then we will discuss the Hofmann degradation of 1 degree amines. Then we will discuss the reductive amination of aldehyde and ketones, and lastly we will discuss Schmidt reactions. So heading of today's lecture is the preparation of amines. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First, we are going to discuss the Hofmann aminolysis process. Hofmann aminolysis process. In this process, alcoholic ammonia is reacted with the alkyl halides in a shielded tube at the temperature 373 Kelvin, and it is going to produce a mixture of amines, that is 1 degree, 2 degree and 3 degree amines, along with the quaternary ammonium salt has been produced. Basically, this reaction is nucleophilic substitution reaction. Here, ammonia acts as a nucleophile. After the production of the formation of the primary amine, this is also going to be a nucleophile, and it will again attack the alkyl halides, and there is a series of reactions by which you can see there is a formation of the mixed amines, that is 1 degree, 2 degree, 3 degree amines, and after this there is a quaternary ammonium salt. So let us understand how this reaction proceeds. First, the primary amine is produced. Then with the alkyl halides, this is RX with chlorine, bromine, iodine. Alkyl halides, it is going to produce the secondary amine. And then with another alkyl halide, it will now a nucleophile, because there is a lone pair of electrons on the nitrogen. It will again attack this alkyl halide, and it is going to produce the tertiary amine. Secondary amine is going to produce the tertiary amine, and after that tertiary amine, and after that again it will going to attack this alkyl halide and it will going to produce the quaternary ammonium salt. This is quaternary ammonium salt. Quaternary ammonium salt. Ammonium salt. So what we understand, that there is a series of reaction by which you will find there is a mixture of product. But this is not going to solve our purpose. We want that procedure which will going to yield a main product, and that can be easily done. There is a two reaction condition. Number one, if we take this ammonia in the excess amount, ammonia in the excess amount means 10 times than the alkyl halide. 10 times than alkyl halides. At that time it will going to produce 10 times the ammonia. NH3 is 10 times than alkyl halide. Then it will going to produce the 1 degree amine, that is primary amine. When, second thing, when the alkyl halides is more than, that is alkyl halide is excess. When alkyl halide is excess, alkyl excess, at that time what will be the product? Then the main product will be quaternary ammonium salt. So this is the way by which we can able to synthesize the ammonia, 1 degree ammonia. Second process, that is the reduction process. Reading the reduction process is very, very important and useful process, and we have to understand that reduction means we can use different reagents, and with the use of different reducing agent we can able to produce the amines. How? Let us understand. First, the nitro compounds. From the nitro compounds, both the aliphatic and aromatic amines can be produced by this reduction process. The nitro compound with the use of catalytic hydrogenation. Catalytic hydrogenation means that we are using the hydrogen in the finely divided nickel or platinum or palladium. It is catalytic hydrogenation, and this will reduce the nitro compound into the 1 degree amine. The example is, that is nitroalkane. When we use the hydrogen with nickel catalyst, and it is going to produce the 1 degree amine. The similar way we can use nitrobenzene. Nitrobenzene, and here we are using, changing the reducing agent. We are using a Fe metal, or we can use the zinc, or we can use the SN, or we can use the SnCl2 with concentrated HCl. It will going to produce the 1 degree aromatic amine, that is the amine. So here the reducing agent is this, and here the reducing agent is this. Now if we use the reducing agent, suppose we are using this nitroethane. At that time, if we use the lithium aluminum hydride, it is going to produce this second primary amine is produced. What is this? That is ethyl amine. This is ethyl amine. But if we use this lithium aluminum hydride to reduce this nitrobenzene, what is going to produce? it will not going to produce this aniline, but it is going to produce the azobenzene. It is going to produce the azobenzene with the use of lithium aluminum hydride. This is the nitro compound. Then we can use, this is A. Then you can use the cyano compound, cyanide or isocyanide. If we reduce the cyanide or isocyanide by a proper reagent that you are using, that is, we can use lithium aluminum hydride or sodium ethyl alcohol. Sodium amalgam and ethyl alcohol, both are reducing agent, and it is also called the Mendes reduction. If we use this, suppose we are taking the acetonitrile. This is acetonitrile and we are using the lithium aluminum hydride as a reducing agent. It is going to produce this amine, this 1 degree amine, that is ethyl amine. In the same way, if we use the isocyanide product, this is C6H5N. This is phenyl carbyl amine. This is phenyl carbyl amine, and when this is reduces with the use of lithium aluminum hydride or sodium with alcohol, at that time it is going to produce the amine which is not primary but secondary amine. What is the name? Name is N-methyl. Name of this amine is N-methyl aniline. N-methyl aniline. So by using the reduction, you can see from different reagent, you can able to produce the amines. See that we are using the reducing the amide. When we reduce the amide, at that time also we can get different types of products. If we use 1 degree amide, you can get the 1 degree amine. If you use the 2 degree amide, if you get the 2 degree amine, and 3 degree amide, if you get this 3 degree amine. So here also reducing agent, suppose you are using this. This is amide, this is 1 degree amide. When the reducing agent you are using lithium aluminum hydride, at that time it is going to produce 1 degree amine. If it is, this is 1 degree amide and it is produced the 1 degree amine, that is primary amine. But if we use the secondary amide is this. This is secondary amide. Then it is going to produce the so this is the second degree amide. So if we change the amide, you can also change the product also. So this is the reduction process we are discussing. Now we are going to discuss another very important, that if we reduce the oxime product, that can also going to give you the amine. Now we are going to discuss the reduction of oxime. Reduction of oxime. Reduction of oxime. This is alloxy. When this alloxy is reduced in presence of lithium aluminum hydride, at that time we will get one degree amine. This is 1 degree amine. You will get this 1 degree amine. In the similar way, if you use the ketoxin with lithium aluminum hydride, it is again going to produce the 1 degree amine. Now we are going to discuss another important process, that is the hydrolysis. Number 3, hydrolysis of isocyanate. And in this case, when you are going to process this hydrolysis, we have to always remember that it will be the acid hydrolysis. So we are taking this is the alkyl isocyanate. This alkyl isocyanate in the hydrolysis with the H plus ion, this H plus ion will take up this lone pair of electrons and it will going to form this . Now it will again going to react with the H2 and it is going to form here when going to take the H2, at that time this electron pair will be taken by lone pair, this one pair electron taken up by this nitrogen, and this will go to as a OH. So you will find this, there is a double bond here and CH and OH, and this is again going to tautomerases. This molecule will be tautomerases, and it is going to produce this NHCH, and now with this hydrolysis it will going to produce this NH2 and it will going to produce the formic acid. So these two products, 1 degree amine you can observe and formic acid with the hydrolysis of isocyanates. Now second, that is the fourth process that we are going to discuss, is a very important process, that is the Gabriel phthalimide synthesis. In this case, the potassium salt of thalamite has been reacted with the ethyl alcohol, alkyl halides, and it is going to produce the 1 degree aliphatic amine. So let us see the reaction. This is we are taking the substituted ethyl substituted thalamite in this way. It is basically a nucleophilic substitution reaction. Here this is basically, this is plus and this is minus, and this is act as a nucleophile, and this nucleophile act as this alkyl iodide, and it is going to produce this. And when this is hydrolyzed, this can be hydrolyzed in presence of H plus, or this also hydrolyzed in presence of the alkali. It is going to produce the phthalic acid. We are going to produce the phthalic acid and the ethyl amine, that is 1 degree amine. Okay, this is the gradual thalamite synthesis. Okay, now we are going to discuss another 2 important reactions. It is a very important reaction, that is the Hofmann degradation reaction. Degradation of 1 degree amide. Hofmann degradation on 1 degree amide. And this reaction is carried out with the bromine in presence of KOH. Suppose we are taking this amide, this is propion amide, and this propion amide, it reacts with the bromine and KOH. This is going to form this primary amine, that is ethyl amine. And another product that we are going to produce, that is K2CO3, or it will produce the KBr and H2O. So here you can see this amide produce this 1 degree amide, but here the carbon atom is less than this, 1 carbon atom less than this amide, and this is called the Hofmann degradation reaction, because it carbon atom has been reduced. Here 3 carbon atom is there, now it is 2 carbon atom. In the same way, from the benjamide, with the use of this bromine and KOH, you can have also aniline. Here also you can see there is 1 carbon atom less here. So this is Hofmann degradation of 1 degree amide reactions. Next reaction, that is the reduction amination. Reduction amination. Reduction amination. Reduction amination of aldehyde and ketone. Aldehyde and ketones. Here, both aldehyde and ketone can be transformed into the 1 degree amine by the use of the ammonia, and which is reduced. The reaction is this. This is aldehyde, and when it will react with the ammonia, so it is going to produce this. This is aldeamine. This product is aldeamine, and this aldeamine, when reduces in presence of hydrogen with nickel, and this is going to produce this primary amine. Basically, first ammonia will react with this, produce the aldehyde, and after that there is a reduction and it will going to produce the 1 degree amine. In the same way, from the ketones also you can able to produce this. Here, what is happening here? There is one molecule of H2 has been eliminated. So, this is for the ketamine. So, again, this is reduced and it is going to produce this 1 degree amine. The next reaction, that is the seventh reaction, this is the CMET reaction. CMET. This is CMET reaction. In this reaction, that is a very important reaction. The reaction is carried out in presence, it is given by the carboxylic acid plus NH3, carboxylic acid and hydrazoic acid. This is hydrazoic acid, N3H, in presence of H2SO4, and this is going to produce the primary amine along with the carbon dioxide and N2, nitrogen. So this is hydrazoic acid. It will react with this carboxylic acid and it is in presence of concentrated H2SO4, it is going to produce this primary amine. So in this lecture we have discussed 7 very important reactions of preparation of the amines, and this will be very much helpful because in the exam this type of reaction may come and you have to say what will be the product at that time. You have to remember it. So this is the in this lecture that we have end of this lecture, and hope all the points that we have clarified to you, that is been clear to you. And the next lecture we will discuss about the physical and chemical properties of the amines. Thank you very much for watching.